In today's tutorial, we want to consider one important aspect of physics that we call current electricity. And we are going to use this question to explain some concepts under current electricity. So what is the concept I want to explain this morning? Two resistors, R1 and R2. So the concept is resistor. Let us just pick the concept resistor and its resistance. All right, so this is the concept we want to consider today. Resistor, resistance. So the question said that we have two resistors, R1 and R2. This was given in the question, R1 and R2. And they are connected in parallel. So the connection is what? Parallel. Please take note of this parallel because we are going to be dwelling more on parallel. Next information in the question, R2, please take note, R2 being greater than R1. That means if R2 is 5, then R1 cannot be up to 5. So R1 will be either 1, 2, 3, 4, as the case may be. However, R2 must be greater than R1. Now, the combined resistance, combine the two resistors together. If you combine them together, the resistance now, what is it going to give us? A, is it going to be less than R1? Is it going to be greater than R2? Is it going to be the sum of R1 and R2? Is it going to be the difference of R2 and R1? Is the combined resistance. Let us use RT to represent combined resistance. The combined resistance, is it going to be greater than R1 or less than R2? All right, my name is Tokupo. Are you planning to write any exam? Make sure you contact me. All these questions, we solve them like ABC. All right, without wasting time, let us understand the concept of resistor and resistance. In an electric circuit, that is the path given to the flow of an electric current, the pathway through which or by which current flows in an electric circuit is called an electric circuit. Now, in an electric circuit, there are various components that you can see inside an electric circuit. I'll mention like 2 or 3 for you. You can see this resistor I want to talk about. You can see a resistor in an electric circuit is one of the components. You can see capacitor, you can see inductor, you can see diode, and you can see a lot key, cell, ammeter, voltmeter, galvanometer, and so on and so forth. Now, this resistor, when they are in an electric circuit, what is their function? Resistor function as an opposition to the flow of electric current. Don't forget that resistors are insulator. And because resistors are insulator, that means they do not allow electricity to flow through them easily. Unlike conductors that allow electric current to pass through them very, very easily. But resistors, they are insulator. Hence, they don't want electric current to pass through them. They are always opposing the flow of electric current in an electric circuit. That opposition that is offered by a resistor is what we call resistance. Because they are insulator, that means that resistance, they have high electrical resistance. They are what? They are high electrical resistance because they have high electric resistivity because they offer opposition to the flow of what? Electric current. Resistors, the symbol for resistor is, we denote resistor with letter R, and the symbol in a circuit is like this. If you see any symbol like this, it's talking about resistor, or sometimes you can see something like this. This is also a resistor. These are the diagrams that we use to represent resistor. And the unit of resistor is ohms. Is what? Ohms. Drawn like this. So if I say 10 ohms, just know that I'm talking about resistor. All right. So now the main concept for today is arrangement of resistors. Is what? Arrangement of resistor. How do we arrange resistor? There are two ways we can arrange resistor. in an electric circuit. One is we can arrange resistors in series, and two, we can arrange resistors in parallel. Please take note, resistors can be arranged either in series or in parallel. Series do not usually have issue. When two or more resistors are connected end to end, I'm going to be making use of two resistors because this question is talking about just two resistors. So this is resistor 1 and this is resistor 2. If you see anything like this in exam, probably you have been seeing diagrams like this. Don't panic. This is an electric circuit, but this is not complete because the key is not here, cell is not here, ammeter. But I just want to show you the part that contains the resistors. Now, this line here represents conductor, that is wire. Now, current is flowing in the wire because the wire is a conductor of electricity. On getting here, this resistor here is an insulator. So it wants to oppose or stop current from flowing through it. However, current will still flow through them, but they oppose, they try to stop the flow of current. So this arrangement here is called series connection or series arrangement. What you should know about series arrangement: number one, the same current will flow through each of the resistor. If the current flowing in the circuit is 0.5, that means 0.5 current will flow through resistor 1, 0.5 current will flow through resistor 2 if they are connected in series. Number two, different potential difference. So the potential difference, that is the voltage or the electromotive force, these are the three things they can talk about under potential difference: either potential difference, voltage, or electromotive force. Now, this electromotive force here that is going to be passed through them will be the same once the current is different. It will be different rather because the current is the same. And finally, if I want to join all these resistors together here, that is combined resistance, the combined opposition, is just add each of the resistors together, and that has given you the total resistance in that cycle. So for series connection, I just need to add R1 and R2. But this question is not referring to series connection. It's talking about what? Parallel connection. Hence, any option that says I should add R1 and R2 together, that option is wrong. So we say less than R1, greater than R2, the sum of R1 and R2. So option C is wrong. In parallel connection, the combined resistance is not the addition of the individual resistors. That is for series connection. Now let's move on to parallel connection. Let's explain parallel connection. And that's the deal of the day. Now for parallel connection, the resistors are arranged and side by side like this. This is resistor 1 and this is what? Resistor 2. So if you see any arrangement like this, we call them parallel arrangements. Of course, the current is flowing. When the current gets to this junction here, let's call it junction P. Let's call here junction Q. The current is splitted into two. As you can see, the wire branch. That means that this current here is splitted here as I1 and what here as I2. That means that in a parallel connection, different currents flows through the resistors, but the same PD. So that is the difference. Same PD, same voltage or electromotive force as the case may be. And finally, if I want to combine the resistors together, I'm going to say this time around is going to be the reciprocal 1 over RT. Of course, this has a proof, but we are not making use of the proof today. 1 over RT is equals to 1 over R1 plus 1 over R2. So this is how you combine. Don't forget that RT means combined resistance. If they are in parallel, this is the formula you're going to use to combine all the resistors together. Am I making sense? Yes. Now, let's now solve this question. I'm going to assume that R1 is 2 ohms as well as R2 to be what? 5 ohms. You can use any figure of your choice, but ensure that R2 is greater than R1. Just make sure that R2 is greater than what? R1. All right, so What is next I'm going to do? I'm going to combine them together. That is 1 over RT is equals to 1 over 2 plus 1 divided by 5. So 1 over RT is equals to LCM of 2 and 5 is 10. We now say 10 divided by 2, 5. 5 times 1, 5 plus 10 divided by 5, 2. 2 times 1, 2. And you see 1 over RT is equals to 5 plus 2, 7 divided by 10. So I'm going to cross multiply. 7 times RT, I have 7 RT is equal to 10. Then I'll divide both sides by 7. 7 cancels 7. So this means that the combined resistance in this circuit is 10 divided by 7. That is 1.43. Now, look at that work. The combined resistance here is what? 1.43 ohms. Let's now look up. If the combined resistance is 1.43, is it less than R1? Is it greater than R2? Is it less? No. Let's check the option. A, the combined resistance is less than R1. Let's check. What is the combined resistance? 1.43. You see that 1.43 is less than what? R1, which is 2. That means that for parallel connection, the combined resistance must be less than the smallest or the least. The combined resistance, pay attention to that, is the keyword there. The combined resistance must always be less than the least resistor. Than the what? The least resistor. That is what happens in parallel connection. So 1.43 is less than the least resistor here is what? R1, which is what? 2. That means option A is very, very correct. Now option B, the combined resistor is greater than R2. No, combined resistor is 1.43 and R2 is 5. You can see 1.43 is not greater than 5. So that one is not possible. So option B is wrong. Of course, it's the sum. I've said this one is series arrangement. The difference, it can't be difference. The combined resistor cannot be the difference between R2 and R1 because RT is 1.43. So it's not, if I subtract 5 and 2, I'll get 3. So it's not R2 minus R1. So what I'm trying to say is this. If it were to be series connection, the combined resistance will be greater than the highest resistor. It will be greater than the what? Highest resistor. Take note. The combined resistance. Let's combine these resistors together in series. That will be 2 plus 5. That is 2 plus 5. That's going to give us what? 7 ohm. You see that 7 is bigger than the highest resistor. So it will have been, if you were to be in series, it will have been greater than R2. Do you understand it now? And I can also go for the sum of R1 and R2. So option B and C will have been very correct if they were arranged in series connection. Do you understand it now? So that's how you solve this question. As you can see, it's not hard. You just need to understand 1 or 2 concepts and you are good to go. Please, I am available. Online class, physical class, theoretical part of physics for schools, for students, just contact me. Explanation show, and we are going to take it simplicity, step by step. Thank you. My name is Tokoko. Do it to share this video and follow my page for more video. Bye.